In this video, I'm going to show you how to make your own tools for checking your wheel alignment at home. Hello, I'm Bob, and once again I'd like to welcome you to another episode on the White Dog Garage YouTube channel. So what we're doing is we're making two T-shaped frames that will be used to check the toe and camber on the vehicle. Can also be used to check the caster. The caster tends to be a fixture of the vehicle design. Toe and camber, however, are subject to wear and tear with driving, and these are the things that you need to have a look at every now and then. Initially my design was a crossbar as shown in this page from my sketchbook. The spacers make sure the frame clears the sidewalls of the tyres, which may be uneven. It covered both the camber and toe measurements, but I was concerned that the centre bolt could distort the frame, leading to incorrect measurements. Giving the design further thought, I sketched an upside down T-frame with fish plates holding the frame together. This limited the chance of significant distortion during fabrication and use. The use of the 3 spacers instead of 4 should make positioning easier on the rim, as well as ensuring the frame is parallel to the rim. So I decided to go with the inverted T design. I'm standing here ready to cut. I've got a length of 25.4mm square box section aluminium. That's 1 inch square box section aluminium. You could use steel. I'm using aluminium because it's light. The important thing is that it's straight. It needs to be straight, otherwise you have deviations in your measurements that you don't need. I am using our compound miter saw to cut the box section, fitting it with an aluminium cutting blade before use. I've seen plenty of workers just use a wood blade on light aluminium like I'm cutting here, but the aluminium blade with its negative rake or hook angle gives a smoother and more accurate cut. I apply paraffin wax to the blade as the lubricant before cutting. The crossbars or top of the T are 800mm or about 31.5 inches long. The uprights or leg of the T are 420mm or about 16.5 inches long. To join the leg to the top of the T, I'm making a pair of fish plates out of 1.2mm thick aluminium checker plate. These will be riveted either side of the 2 pieces to make the T-frame. The dimensions of the fish plate are as shown in my earlier sketch of the T-frame, but re-shown here on their own. I use a hacksaw with 32 teeth per inch blade to cut out the fish plates. The choice of cutting tool depends on what's available, of course, and aircraft snips certainly make a quicker cut, but they also deform the aluminium. But this distortion can be flattened out again with a hammer, but maybe it's not so quick in the end. Assembling the frame is straightforward. The upright section or leg of the T is perpendicular to the centre of the crossbar or top of the T. Clamped in place on a flat surface, a fish plate is riveted to one side. The clamps are then released, the frame turned over and the second fish plate riveted to the other side. Off camera I have cut strips of sheet metal which I pre-drill and then rivet to the crossbar and the upright. It's only later that I realised the strip riveted to the side of the upright is in the wrong place and I had to remove it and reattach it to the front of the frame. Where it was would have been great for measuring the caster angle, but I wanted at the front to measure the camber angle. For the T's, I need to make some offsets. I'm going to make my offsets about 100 millimeters long. They need to pass through the T and be bolted on either side, or have a nut on either side, so that the offset distance can be adjusted in or out. The reason you do that, of course, is that tyres can swell at the side and you want the offsets on the rim, not on the tyres, because they can be distorted. I was going to use some threaded rod, and you could use threaded rod. Unfortunately, I've got 6 offsets to make and they need to be 100 millimeters long. That's 600 millimeters, and I've only got about 350 millimeters here. So what I'm using is some 100 millimeter, 8 millimeter diameter bolts, M8s, and they're only short thread. So I'm going to have to turn extra thread here, and I'll just do that with a simple thread die. I'm extending the thread on the bolt to about 60 millimeters. If you're interested, the cutting compound I'm using is Trefolex, a CRC product. It's my go-to cutting compound for hand-driven tap or die threading. Looks easy work at 5 times normal speed, but when you have 6 of them to do, threaded rod becomes much more appealing. Still, we're making do here. With the thread extended, it's off with the head of the bolt and then over to the grinder to give the bare end a point. Point does not need to be sharp, just tape it enough so that it fits firmly against the wheel rim. I've worked out my hole pattern just using the various wheels that I've got around the place, 14 inch, 15 inch, 16 inch and 17 inch. So we start with the 2 bottom ones. They're an equal distance apart and I've made them 150 millimeters from the edge, see this edge of the upright. It's not really that specific, so I'm using a felt tip pen rather than a scriber. Now I've only gone with 3 measurements up here. The 17 inch wheel has a big flat surface that allows me to use the 16 inch setting for it. So I'm going with a 14, a 15 and a 16. So from the bottom of what is effectively the top of the T, but I'm calling it the bottom of the T, the first one is at 282 millimeters. So this one's 321. and the top one is 357, which is the 16 and 17 inch. Recapping, the bottom offsets are positioned 150 millimeters each side of the upright or leg of the T. The top offset holes are respectively 282, 321 and 357 millimeters from the bottom of the crossbar or top of the T. The crossbar or top of the T sits low on the rim so that the toe measurements are not obstructed by mudguard or fender and suspension components. And because it's 1 inch box section, I have an inch rule, of course, and it's a 1/2 inch into the centre. And the holes I'm drilling are just 8mm diameter. They're 8mm bolts, but 8mm bolts are always slightly under the 8mm diameter on the thread, and that means it'll be a nice tight fit in the hole. So I'm going to give a demonstration of how these work, measuring both toe and camber. Now before I do that, what I need to do is to make sure that each one of these offset pins is an identical distance from the frame. Doesn't matter what the distance is, what you're setting up to do is to clear the tyre so that the pins all rest on the actual wheel rims. The offset of these need to be set accurately. You can do it with a ruler, but what really needs to be is that they are an exact distance from the frame. Because we're talking about a couple of millimeters usually in the toe and less than a degree in the camber. Now you can do this with a ruler, but I'm going to show you a special tool that I have, and I'm going to set them with it. The tool that I have is a very simple one. I made it some time ago to actually set the height on my router bench, particularly the router tools, making sure they are a particular distance. So you can buy these. They usually come with a digital gauge that measures your height above or below. I've made this one just with a simple pin. I can always measure the distance if I need to, and that's what I do for the router tool, which is what it was primarily made for. Anyhow, so what I'll do now is I'll set the height, and hopefully this will be the same from pin to pin. That one's a little low, and that one's almost spot on. So it's just a matter now of just going around and adjusting. Now I'll do both T's the same, but you don't have to. The critical thing is that the 3 pins on each T are the same distance from the frame. I'm going to get you up to speed with the use of the T frames, but before I do that, I need to get you up to speed with what you're actually doing, measuring toe and camber, and the sort of measurements you should be looking for. Toe is the amount the front wheels turn either in or out, and camber is the tilt of the front wheels either in or out. So I've got to look at my diagrams. So these are exaggerated. So when you're looking at toe toe in, the wheels are turned in, toe out, the wheels are turned out. That's facing forward. So how it goes is that if you've got a rear wheel drive vehicle, you normally want these wheels turned in slightly. That's because when the drive comes at the rear, it tends to want to push the wheels out. So you have a slight toe in to accommodate that. And toe out obviously is when the wheels face out. And in front wheel drive vehicles you normally want a slight bit of toe out, because when the drive comes on the wheels tend to turn in. And the sort of measurements you're generally looking at is about 2 to 6 millimeters of difference on the toe in and about 2 millimeters of difference on the toe out, depending on where your vehicle's driving from. Now, when you measure it, you actually need to be measuring the rims, and I'll talk about that in a minute with an actual wheel demonstration. But just to give you an idea, you don't normally measure with bare rims, so you're faced with your tyres. We have the offset to account for any or lack of uniformity in the tyres, and also so that we actually get on the rims and clear the tyres. So we end up with a measurement out here, and a measurement in front, a measurement behind the front wheel, which has to be sheeted home to the actual rim, and I'll talk about that in a minute as well. Now, camber is the tilt, and you normally say you've got positive camber when it's out at the top, and negative camber when it tilts in at the top. These wheels are shown tilting out. Usually the sort of measurements you're looking for camber is about 1/4 to 1/2 degree positive camber, which means that you want the wheels slightly out at the top. Now the sort of measurement you're looking at, as I said, is 1/4 to 1/2 degree. It's often given in minutes. There are 60 minutes in a degree, so you're talking 15 to 30 minutes in your camber measurement. Toe in is usually given in millimeters or fractions of an inch, depending on what country you're in, or where the vehicles come from. If you're into performance, and we're really talking about the race situation here, you might have a definite tip in on the front tyres, real negative camber, and the reason for that is that it gives you better cornering. You might also have no toe or zero toe, and that gives you a more responsive steering. But you have to remember with performance racing, the tyres very short life. What the manufacturer has given you in toe and camber is designed for your tyres to last as long as they can. The assembled tools for measuring toe and camber: the 2 alignment tees, 2 stretch straps, a digital angle meter and a tape measure. Now, things didn't go exactly as I've shown to date. I put a metal plate on the inside, but we need to measure the angle from this face. So I've had to change the metal plate to the front. The other thing that I've done is that I have put lines along here at distances 275 through to 375 millimeters from the upright, and the purpose of this is that when it's up against the wheel, you need to be measuring the same distance from each end. So when you're going across to measure the toe, you need to align with one of these lines. And I don't know how well you'll see that. There's a series of lines there, and I've actually scribed in numbers as well. Resist the temptation to punch numbers in, because that can distort the frame. Before I go and demonstrate its use in the real world, I just want to talk about the setup. So the vehicle needs to be on level ground, pretty well level ground. Front wheels need to be facing directly forward. This is the setup, just a strap to hold it in place. I've just set up a wheel here just to sort of go through a few issues. I've got marks here, front and back, which are set distances from the centre and which are used to align the tape. The tape needs to go the same distance in the front of the wheel as it does at the back of the wheel. The way that works is that if you know the distance here, you know the distance between where you measured at the front and where you measured at the back, they can be related to the actual rim distance. So I'm out at the caravan, and I'm going to use the caravan's front wheels as the demonstration of the measuring the toe and the camber. Now, there's a few things you need to keep in mind. This bar needs to be perfectly level. I'm using the digital level box, but you can just as easily use a level, a small level obviously. I have also highlighted and numbered the reference lines for measuring the toe. You can do all of this mathematically if you want, but the other thing you need, of course, is the tape measure. I need to clear the tyre, and I'm going in front of number 3. And we'll call that 57. It's actually 2,357. And we go behind the wheel. And again, we're in front of number 3, which is 325 from the centre, and we're calling it 57 as well. So what that means is that we have a toe of 0 front to back. I don't need to come back to the actual rim measurements. Now, the way it works for the camber is you just put the magnetic digital level against the top. You can put it against the magnetic plate, or you can put it against the steel plate, but you don't have to do that. You can just put it against the top. Here it's reading 89.3, so it's 0.7 of a degree is our camber. Reviewing the results from the caravan, the front and back toe measurements were the same, giving 0 or neutral toe, neither toe in nor toe out. The measured camber angle was 89.3 degrees, which means the wheel is tipped slightly out at the top, and it has 0.7 degrees or 42 minutes of positive camber. This caravan has independent suspension on all 4 wheels. Tyre wear is good, and the toe and camber measurements are acceptable to me. I've never seen the manufacturer's toe and camber settings for that caravan. In fact, here in Australia, the manufacturers tend to keep it all a big secret with their dealers as to what the actual specifications are. You can look low and high, and it's a fair bit of detective work to find out the actual settings for your vehicle. Not so overseas, I don't think. I certainly know that I can look online and find the tow and camber settings for most American cars and trucks. That said, the tow and camber measurements are generally a function of the suspension system and the drive system. So they can be a bit generic across different models as long as they share the same suspension and drive setup. And you may well have moved, you probably almost certainly have moved beyond the factory original equipment tyres, so it becomes a bit of a moot point as to what's the best settings for your vehicle. They'll fall within a range for that type of vehicle, but they may alter a little to get the best use out of your front tyres. When you do find tow measurements, they're often angles, not distances, and there's a reason for this. The tow measurements really relate to the rims on the vehicle, which in turn relate to the front hubs. This is why I've shown you how to make these simple frames rather than just using a straight edge across your tyres or front wheels of your vehicle. But if you need the distance rim to rim or an actual angle distance related on the rim, then I'll show you how to calculate that simply and easily from the measurements that you take and from the measurements that refer to the T-frames that you've made. Here we have two diagrams. The first one shows the vehicle's two front wheels with exaggerated toe in. The yellow centre is the rim and the blue outer the tyre. The second diagram shows one wheel with a pair of upside down right-angled triangles drawn across it. This second diagram shows the basic measurements, both known and unknown, that we need to consider when calculating the rim-based toe distance and toe angle. The example I'm going to use is toe in, but toe out is calculated in a similar way. What do we know? Using the T-frames, we have distances in front of the wheel, which I've labelled F, and behind the wheel, which I've labelled B. The difference of these two is the wheel toe in, and I've not labelled it here, but I'm calling it T. Each of the two front wheels will share half of the wheel toe in, and I've labelled that as T apostrophe. We also know the distance along the T-frame crossbar between where we took our front and back measurements, and I've labelled that D. We also know our rim diameter, which I've labelled A. Now, these values can be used to calculate the half measurement of the overall rim toe in, which I've labelled X, and the angle of the toe, which I've labelled alpha. Note that for the two right angles drawn here, the included angle alpha is the same for the right angled triangle with the rim diameter A as its hypotenuse, and the right angled triangle with the distance along the T-frame crossbar D as its hypotenuse. Moving on to calculations, the wheel's toe-in value is the difference between the front and back measurements, which I've called T, and for each wheel it will be half of the value of T, which I've labelled T apostrophe. Dredging up some trigonometry here, the sine of the included angle in a right-angled triangle is the length of the opposite side divided by the length of the hypotenuse, which means that the sine of the included angle alpha equals half the measurement of the overall rim toe in, labelled X, divided by the rim diameter, labelled A. But the sine of alpha is also equal to half the value of T, labelled T apostrophe, divided by the distance along the T-frame crossbar between the front and back measurements, labelled D. How convenient for a bit of algebraic manipulation. X divided by A is equal to T apostrophe divided by D, and as X is our only unknown, we can solve for X by multiplying A by the result of T apostrophe divided by D. So we now have the formulas for calculating the rim toe in distance, which will be 2 times X, and the toe angle, which will be the inverse sine, that is, the angle for which the sine is T apostrophe divided by D. So let's look at a real world example. The vehicle we checked had 17-inch rims, which is a rim diameter of 432 millimeters, which is our value for A. The toe measurements were taken at a separation across the crossbar of 725 millimeters, which is our value for D. The toe end measurement we got was 2 millimeters, so our T apostrophe value is half that at 1 millimeter. Keying these values into our equation for the individual rim, we get 0.6 of a millimeter, and our rim to rim toe in is twice that at 1.2 millimeters. Now, we actually have a toe angle specification for this vehicle, so we can determine our toe angle by finding the inverse sign for T apostrophe divided by D, which in our case is 1 divided by 725. When we key that into our calculator and hit the sign to the -1 function, the angle is 0.08 degrees. The vehicle in question is a Ford Ranger, and the toe angle specification for it is 0 to 0.15 degrees. So we're good. Well, I hope you enjoyed the video. I hope you found it useful if you're looking to check your own wheel alignment. If you liked the video, then I'd appreciate a thumbs up. And by all means, share it with your friends, share it with people who aren't your friends. It's all good. The White Dog Garage YouTube channel is about maintaining things, fixing things, renovating things and making things. And if you like that sort of stuff, then maybe this is a channel for you. So if you haven't already subscribed, well, it's easy. Just hit the subscribe bar down below. While you're there, ding the bell so that you get a notification from YouTube the next time an episode airs on the White Dog Garage YouTube channel. Thanks again for watching. I look forward to talking to you in another episode. Bye.